Assalamu alaikum dear students. Let's continue question bank with solution of chapter 1 units and measurements. In the last lecture we had discussed 3 questions of SA2 carrying 3 marks each. Now after that we are having the next question number 4. Explain with example how is dimensional analysis used to convert the unit of a physical quantity from one system to another system of units. As one of the uses of dimensional analysis is that to find the conversion factor between the units of the same physical quantity in two different system of units. So here it is given, we have to explain this use with the help of example. So here we are considering the example as to determine the conversion factor between the units of the work in two different system of units there. So first of all we are supposed to write down the dimension of the physical quantity as we had considered here for work. So for work done, what would be the conversion factor from SI system to CGS system and hence from CGS system to SI system. So first of all we have to write down the dimension of the work there, which is L2 M1 T minus 2. After writing the dimension of the physical quantity, we have to write the equation in terms of their units in SI system and CGS system. As CGS system is the smaller quantity, we can write as when we are comparing with the SI system. So here we can write the SI system unit is equal to some conversion factor which we are denoting here as X into CGS unit. So for the work done, the SI unit is joule and in CGS unit the work is measured in erg there. So we have to write 1 joule is equal to X erg, where X is the conversion factor between the units of the physical quantity work in two different system of units there. After writing this equation, we have to write down the dimension. So the dimension of work done in any system would be same. So here we are supposed to write the dimensional formula for 1 joule as L2 M1 T minus 2. As we have to specify the suffix 1 to indicate the SI units there. So it is to be written as L1 power 2 M1 power 1 T1 power minus 2 is equal to X. For erg we have to specify the suffix 2 to indicate the CGS units there. So for the erg, the dimension of the work in CGS system is to be written as L2 raised to 2 M2 raised to 1 T2 raised to minus 2. After writing the dimensions in SI system and CGS system, we can write the value of X is equal to L1 M1 T1 with their respective powers 2, 1 and minus 2 is divided by L2 M2 T2 with the respective powers 2, 1 and minus 2. That means this left hand side dimension is to be divided by the right hand side dimensions there. After writing this equation, we have to segregate by means of the physical quantities L, M and T. So here we have to write L12 divided by L2 square, then m1 raised to 1 is divided by m2 raised to 1. T1 raised to minus 2 is divided by T2 minus 2. Then in the next step, here we can simplify the equation as, for the L having the same power, so it is to be written as L1 upon L2 raised to 2. For M, it is also having the same power, so we have to write M1 upon M2 raised to 1. And for the time, again we are having the same power, so we have to write it as T1 upon T2 raised to minus 2. Then in the next step, as L1 M1 T1 represents the SI unit and L2 M2 T2 represent the CGS units. So here we are going to write the CGS and SI units there. So the SI unit of length, that is L1, is to be written as M, and L2, which is the CGS unit of length, so it is to be written as centimeter. So here we are getting L1 upon L2 raised to 2, we have to write in terms of unit as meter upon centimeter raised to 2. Similarly for the mass, M1 is the SI unit of mass and hence it is to be written as kilogram, and M2 is the CGS unit of mass, which is to be expressed as gram. So M1 upon M2 raised to 1 we are getting as kilogram upon gram raised to 1. Now for the time, the unit in SI system and CGS system is second only, so we have to write second upon second raised to minus 2. Now in the next step, here we have to convert either a units there. As we know that 1 meter is equal to 100 centimeter. So our equation becomes more simplified over here. So here we are converting the SI units into CGS units. So 1 meter is 100 centimeter, so it is to be written as 10 raised to 2 centimeter divided by centimeter, the whole power 2. Then kilogram upon gram has a power 1, so we have to write kilogram is equals to 1000 gram, and hence we have to write it as 10 raised to 3 gram upon gram raised to power 1. Then second upon second will be cancelled, remains with 1 there raised to power minus 2, and 1 raised to minus 2 is remaining with 1 only. Then in the next step, centimeter gets cancelled, we are left with 10 raised to 2 into 2. Then gram get cancelled, we are left with 10 raised to 3 into 2. And finally we have to multiply the powers there, and when we are multiplying the powers, so 10 raised to 2 into 2 would become 10 raised to 4 into 10 raised to 3 is there. Now for the same base we have to add the powers, and hence finally 10 raised to 4 into 10 raised to 3 we are getting as 10 raised to 7. That means the value of x we are getting as 10 raised to 7, which is unknown initially when we had considered that 1 joule is equal to x erg. So now substitute the value of x in this equation, and hence finally we are getting 1 joule is equal to 10 raised to 7 erg. So this is the conversion factor between the units of the physical quantity that we here we had considered work in two different system of units. That is 1 joule is equal to 10 raised to 7 erg, and 1 erg is equal to 10 raised to minus 7 joule. So by using the dimensional analysis, we can find the conversion factor between the units of the same physical quantity in two different system of units. Now let's have the next question, number 5. Find the conversion factor between SI unit and CGS unit of density. So here the physical quantity is given. So for this physical quantity only we have to find out the conversion factor between SI and CGS system of units there. As in the previous question, no physical quantity is given, so as per our choice we can take any physical quantity, and hence we have to find out the conversion factor between the units of same physical quantity in two different systems of units. But when the physical quantity is mentioned here, so we have to determine the conversion factor for the given physical quantity only. Let's have the solution. So first of all, here we have to write the dimension of the density, which is L raised to minus 3 m raised to 1 t raised to 0. Then in the next step we have to write down the SI unit of density is equal to x into CGS unit. So SI unit of density is 1 kilogram per meter cube is equal to x into CGS unit of the density is gram per centimeter cube. Now give it equation number 1. In the next step we have to write down the dimension of the density, as suffix 1 indicates the SI unit and suffix 2 indicates the CGS units. So here we have to write L1 raised to minus 3 m1 raised to 1 t1 raised to 0 is equal to x. For the CGS units, suffix 2 is there. So here we have to write on the dimension in CGS system as L2 raised to minus 3 m2 raised to 1 t2 raised to 0. Then the value of x is to be written as x is equal to left hand side term divided by right hand side term. After that we have to segregate by means of the dimensional quantity, that is LMNT. So here we have to write L1 raised to minus 3 divided by L2 raised to minus 3 in one bracket. In another bracket m1 raised to 1 and divided by m2 raised to 1 we have to write, and in the third bracket t1 raised to 0 upon t2 raised to 0 we have to write. Then after getting this equation we have to write down the SI units and CGS units of density. So L1 represents the SI system of length there. So here L1 raised to minus 3 is there. So SI unit of length is meter. So we have to write it as m raised to minus 3 divided by L2 raised to minus 3, where L2 gives the CGS unit of the length which is centimeter, hence we have to write as centimeter raised to minus 3. Then for the mass m1, the SI unit is kilogram and the CGS unit is gram, so it is to be written as kilogram raised to 1 upon gram raised to 1. And for the time, the SI unit and CGS unit is second only, so it is to be written as s raised to 0 upon s raised to 0, which would be 1 only. Then we have to convert the SI units into the CGS units of length, mass and second. As 1 meter is 100 centimeter, so here we have to write 100 as 10 raised to 2 centimeter. So 10 raised to 2 and the power is already there minus 3. So here we have to write it as 10 raised to 2 into minus 3. And centimeter is there, but the power is given as minus 3. So we have to write centimeter raised to minus 3 divided by centimeter raised to minus 3. And for the mass, 1 kilogram is 1000 gram, which is to be written as 10 raised to 3 gram, as power is 1. So simply we are writing 10 raised to 3 gram upon gram. S raised to 0 upon s raised to 0 is 1. Now centimeter raised to minus 3 gets cancel here, gram gets cancel here. Here we are left with 10 raised to 2 into minus 3, which would become 10 raised to minus 6 into 10 raised to 3. And on solving for the same base, we have to add the powers. So minus 6 plus 3 is minus 3 only. So 10 raised to minus 3 is remaining there. And the value of x finally we are getting as 10 raised to minus 3. Now let's substitute the value of x in the equation number 1 as minus 3. So we are getting 1 kilogram per meter cube is equal to 10 raised to minus 3 gram per centimeter cube. So this is the conversion between the SI system and CGS system for the physical quantity density. So here we had discussed the SA2 short answer type of questions carrying 3 marks each. The remaining solution of the question bank for the chapter units and measurements will be continue next time in the next lecture. Thank you.